Today we are discussing combined mathematics. Combined mathematics, one part of the mathematical induction. It is more part of the algebra lesson. It is very important one. That is leading with the argument. Actually, that is leading with the argument. Now we say how to do this. Now, this is a given formula. This is a given formula for arithmetic progression, addition given n over 2 a plus n minus 1b n minus 1b. Right? These are addition to this. Is this true or fail? True or fail? How to detect it? Very easily we can do the using the mathematical induction. Other formula is n1. Sn equal n over 2. All also you done this one. N plus 1. 1 plus 2 plus 3 up to n. Summation of the series given this formula. This formula correct or not? How to say? Correct or not? Is this correct? Some values are substituted. We can determine the correct way of this is not correct. Now we are using this method, mathematical induction. Mathematical induction nothing only using the counting numbers or positive integers. Positive integers. N, positive n, denoting normally 1, 2, 3, 4, 5. In mathematical induction method, using this, first we determine when the n equal 1, is this true or not? N equal 1, true or not? Then we assume any number more than 1. More than 1. That can be 2, 3, 4, 5, 6 like this. Normally we are telling this number Q. This is also integer. We assume that this formula true, is exactly true, n equal p. Now we are going to next step, n equal p plus 1. P plus 1. That means what we done? P equal 1, 1 plus 1. P equal 2, 2 plus 1. P equal 3, 3 plus 1. We have to prove that this is satisfied the condition of the these three. It can n equal p plus 1. N 1 plus 1, 2. When you say p true, p plus 1, prove that 1 plus 1, 2, n equal 2, this one will happen. Exactly true. We can prove that true. Then 3 also true. 4 also true. Why? We return all the 1, 2, 3, 4 numbers more than 1. More than 1. This is a method of using the mathematical induction. Now, this have some conditions for these things, like this. Simply we can say, first of all, try out given formula. Any formula. We say this formula, Sn equal n over 2 n plus 1. Actually, that means 1 plus 2 plus 3 up to n numbers equal n over 2 summation n plus 1. Right? Addition of the all numbers 1 to n plus 1. Now we determine this one. try out when n equal 1. What happened? LHS n equal 1 term. That means 1 term. L equal left hand side LHS equal 1. Left hand side. Right hand side. What happened? Substitute the n equal 1 to here. What happened? Equal half times 1 plus 1, 2 equal 1. Now exactly true about the formula LHS equal RHS. RHS when n equal 1. Now we assume that next step, assume that result true when n equal p. Shall true about n equal p. Now what happens? This can be represented again 1 plus 2 plus 3 plus up to p terms. P terms equal p over 2 plus p plus 1. P plus 1. Right? Then the next final steps is that now we are going to prove the formula n equal p plus 1. How to do that? Now you cannot substitute the n equal p plus 1. Now you cannot substitute the n equal p plus 1. But you have to prove that. How to prove that? Very easy to prove that. Now we get in these terms 1 plus 2 plus 3 plus p. What is the p plus 1 term? P plus 1 term. P plus 1 term. 1 plus 2 plus 3 plus up to p plus 1. Additional term this one. P plus 1 term adding to the both sides, left hand and right hand side. Now we get in here p over 2 p plus 1 plus p plus 1 additional term. Now any calculation method using, now we are going to prove that n equal p plus 1 also this formula prove. How to do that? We can common factor take out p plus 1. Now getting here p over 2 plus 1. Now we are getting here p plus 1 over 2. Inside have p plus 2. P plus 2. This can be right. P plus 1 plus 1. What is this? This is holding this like this upside. Right? When the n equal this formula, this is a formula, what that? Sn equal n over 2 n plus 1. Instead of the n, we are using p plus 1. P plus 1. This represent like this. P plus 1. Instead of the n, using p plus 1. We proved already. Actually, we can say the result is true when the n equal p plus 1. We can say final step result true n equal p plus 1. P plus 1. Now we already assume n equal p result is true. Then n equal p plus 1 also result proved already satisfied the condition. Now we can see mathematical induction theory. What to do? Mathematical induction theory. All the positive integers of n, the result is true, result is true, right? Over the positive integers, the formula already proved for true, right? This is the mathematical simple condition, right? Now we are doing now some. This is related to the simulation type questions, some are, right? First question is this one. 2 plus 4 plus this one. 2 plus 2 plus 4 plus 6 plus 2n equal, and that equal n over n plus 1. This is the correct formula. We have to use the mathematical induction, going to prove that this is already satisfied the all the positive integers of n. We say trial out n equal 1. What is happen? Left hand side 2 equal right hand side 1, 2 equal to. We can say now n equal 1, result is true. For that condition, result is true. Now we get in when n equal p, we assume that results true. Actually we assume that result true. What happens? All the n terms replace with the p and additionally use in the p term also. After proving that final step, right? Here we can say 2 plus 4 plus 6 up to 2p equal p times p plus 1. P plus 1. P times p plus 1. Right? Now we assume that. Is that true? Now going to prove that n equal p plus 1 also this one satisfied. Right? How to do that? N equal p plus 1 you cannot substitute to it. Now we get in the p after this term, p plus 1 term, what that? 2 plus 4 plus 6 into 2p plus 2 times p plus 1 equal, here we get in p into p plus 1 plus 2 times p plus 1. Now calculate this one. P plus 1 take out, p plus 1 take out. Here I have p remaining, p plus here p plus 2. Here we getting p plus 1 into formulated that this is corresponding to this type, right? This can be right, p plus 1 plus 1. What is happening? Instead of the n, using n plus 1, p term within result is true. Already proved. Then now we can say in the mathematical induction, all the positive integers of n, result is true. That is the correct way, right? All the steps you have to do, these steps very important. And what I say in statements, that is also very important. Right, remember that. Now, second question. We quickly do all the questions. Ready? It's simple way. Next one is the 1 plus 2 into 2, 2 times 2, 3 times 2 square. This term, n into 2, n minus 1, n minus 1 equal 1 plus equal 1 plus n minus 1 plus n minus 1 into 2n. This formula we have to use using mathematical induction. We have to go into 2. Now we are getting right out when n equal 1. What is when n equal 1? First term 1. 1. Here I have 1. This is 0. Right? This is 0. When n equal 1, result is 2. This is statement. Now when n equal p, assume that result is true. Assume that. We have already assumed. Right. Now we are getting now the p terms. 1 plus 2 into 2 plus 3 into 2 square plus up to p into 2p minus 1 equal 1 plus p minus 1 2 to p. Right. 2 to p. Right. Now we final stage is now we are to going to prove that when the n equal p also this one prove. You have to prove that one. We cannot substitute. Now we are getting p term, taking to p term and both sides add. Both sides add together. 1 plus 2 plus 2 plus 3 into 2 3 into 2 square, square into here. What is the p plus 1 term? P plus 1 to 2 to the power of p equal. This is the additional term. Here I have p 2p minus 1 additional term. Other side also we have to add 1 plus p minus 1 2p plus p plus 1 2p. Right? P plus 1 2p 2p. Now calculate this thing. 1 plus 2p, we have to take out 2p, right? 2p. 2p take out. Now inside have p minus 1 plus p plus 1. P plus 1. 1 cancel. 2p times this one now 2p times like that. Now we getting now 1 plus 2 into 2p. 2p into 2p. Here we can say 1 plus 2 into 2 into p plus 1 times 2 times 2p plus 1. 1 plus will be correct or not? 1 plus n minus 1 2n. 2n minus 1 2p. P plus 1 2. P plus 1 2. 1 correct. This one assume 1 plus 2p. is P plus 1. P term P. That is actually wrong. This is formula wrong. Right? Next question we are doing next question. Something wrong of this question. We also test about that is wrong, but we do that. Now, this one, this is correct. P plus 3, 3 plus 3 square plus 3 cube, 3 cube, up to 3n equal 3 over 2, 3 over 2, 3n minus 1. First step, what's that? First step, n equal 1. What's that? Left hand side 3 equal, right hand side 3 over 2, 3 minus 1, 2 equal 3. N equal 1, result is true. N equal P, assume that result is true. Right? N 3 plus 3 square plus 3 cube up to 3P equal 3 over 2 3P minus 1. Right? All the n terms using for the P. Right? We assume that this is correct. Right? Now, P plus 1 terms, both sides addition, both sides add. 3 plus 3 square plus 3 cube, 3P plus 3P plus 1, no? P plus 1 equal 3 over 2, 3P minus 1 plus P plus 1. Right. Now we are getting what that? 3 over 2. 3 over 2 take up. Inside have 3P minus 1. Here have this one can be right 3P into 3. Already 3 take out. Now here have 3 take out, right? 3P or 3P. 2 times 3P, right? 2 times 3. 2 times 3P. Now we calculate this one. 3 over 2. 3P take out here. 3P times 3. 3P into 1 plus 2 minus 1. This can be right. 3 over 2 times. This is also 3. This is already in the indices using A to P plus 1 minus 1. What is that? Instead of the P plus 1 also proved. P plus 1 also proved this formula. Now we can say mathematical induction theory. All the positive integers of n result is true. Result is true. Right? This one. Now we are taking another one. One different one. Fn equal 810 minus 1 divisible by 7. Divisible by 7. How to prove that? Divisible by 7. First we say F1, n equal 1, F1. F1 is 8 minus 1, 7. Divisible. That means n equal 1, result is 2. Now we assume that when n equal p, result is 2. Then Fp is equal 8p minus 1. Now we have to prove that this results root 4, then that n equal p plus 1. P plus 1. Right. So we have to say in the method you and have here divisible by 7. Actually, this can be right 7n, 7n, right? Multiple of another integer. M is another integer. M is the integer more than 1, right? More than 2 or 1, right? 7n. This can be right 8p is equal 7m minus 1. 7m minus 1, right? Now we take Fp plus 1 for this one. Fp plus 1. Method is like this. 8 to p plus 1 minus 1. This can be right 8p into 8 minus 1. What that 8p? Oh, see, listen. 8p equals n minus 1. This can be right 8 sine 7m minus 1 minus 1 equal 56m plus 7. This can be right 7 times 8m plus 1. M is the integer. What is the 8m plus m? That is also integer. That is divisible by 7. Right? When the n plus np plus 1, that means when the n equal p plus 1 also divisible by 7. Already proved that the formula that can be right in the mathematical index. All the positive values of positive integers of n, Fn equal 8n minus 1 expression divisible by 7. Divisible by 7. Divisible by 7. Right? And already this type of question we have to prove that Fp plus 1 also divisible by 7. Now mathematical induction already proved the condition for this formula. Now another one. The one I have. Xn minus 1, xn minus y to n have factor of one of the factor of x minus y. Minus y. How to prove that? This can be right. Fx equal, Fn equal xn minus yn. Right? When we take n equal 1, result whatever, F1 equal x minus 1. Whatever. X minus y factor having here n equal 1. That is 2. N equal 1, result is 2. X minus y factor have. Now we assume n equal p, this result is true. If p is equal xp minus yp. Right. Now we get in f3 plus 1, 3 plus 1 equal x to the power of 3 plus 1 minus y to the power of 3 plus 1. This can be right x to the power of p plus 1 minus y times yp, y times yp. Yp take here, yp equal xp pi minus fp, right? From here, yp is equal, yp is equal xp minus fp, right? This substitute, what is the one? Substitute here, this one. F p plus 1 equal p plus 1 minus y times yp. Yp is equal xp minus p minus fp. Now we this thing calculate. After calculating having, here I have xp plus 1, here I have this one. This can be right, x p into xx. This can be right, y xp. This can be y fp. Y fp. Take out xp outside, xp x minus y plus y fp. Actually, we know that, we assume that when the fp also have, when the fp n equal p also have x minus y factor. This is have x minus y factor. This is divisible by x minus y. This is already divisible by x minus y. All the quantity. This is fp plus 1. fp plus 1 divisible by what that x minus y. X minus y is the factor of xn to xn power minus yn hat. That is the this one. The final one. Now that's all. Already, thank you very much for watching this one. This is more techniques of the mathematical induction, right? More techniques of the mathematical induction.